In this video, we are going to go over logistic regression. Last time, we learned about the neuron, the smallest unit in a neural network. But now that we know what a neuron is, we might be wondering what a neuron is used for. Well, it turns out that having a neuron can help us do tasks like classifying or generating data. We use a neuron in many machine learning models. As an example, here are two machine learning models that use neurons. Logistic regression is a one-neuron machine learning model, while neural networks contain multiple neurons. Machine learning models like logistic regression and neural networks can both be used to classify or generate data. We will focus on logistic regression. To implement logistic regression, there are a few requirements that need to be met. Firstly, in order to classify our data, we need to have data to classify. So, we need to have our vector of features x. Second, to classify our data, we need to have a function that does the prediction. In this case, we will use a singular neuron. For training a logistic regression model, we will want to have a function that we will optimize. We will use a loss function, which represents how different our predicted class is from a true class. Additionally, for training logistic regression, we need to have a method of optimizing that objective function. We will use gradient descent. Logistic regression has two phases, training and testing. Here are the steps for training logistic regression. Given a training sample, which contains one vector of features x and a true class y for that vector, we apply the classification function to predict the class associated with x. We then compare how far away the predicted class is from the true class using a loss function. We then alter the weights and bias using gradient descent so that the next time around the loss function will give a smaller value. We would want to follow these steps for many training samples until we feel that the logistic regression model performs well. As for the testing phase of logistic regression, using a set of testing samples which should in no way overlap with the set of training samples, we will use the classification function to predict the class associated with each testing sample. We would then compare our predicted labels with the true labels to gather statistics on how well the model performed. These statistics include accuracy, precision, recall, and F-score. We will go over these phases in more detail once we have the tools needed to implement them. These videos were inspired by Josh Starmer at StatQuest. Be sure to check them out.